Each square on this mat is 1 inch wide. If I take a dowel 6 inches long and I lay it down, you can clearly see it's 6 inches long. But what if I start to rotate it? Now it looks 4 inches. Now it looks 3. If I rotate it enough, it doesn't look like it has any width. What's going on here? Believe it or not, the world is 3D. However, the camera only takes a 2D slice of it. So what it's doing is it's taking those 3 dimensions and projecting them into 2 dimensions. Let's make this more abstract and a little mathy. Say that the vector u is our screen and v is the object. If we're looking at the screen, v will look this long. This vector is called the projection of v onto u and is denoted like this. Let's start by finding the length of this vector. The length of the projection will be the cosine of the angle between them times the length of v. This is just SOHCAHTOA. The cosine of the angle between u and v is the inner product of u and v divided by the length of u times the length of v. What? That can't be right. But it is. It comes from the law of cosines. You can draw a picture and do some algebra. The algebra isn't actually all that hard, you just need to remember how the norm is defined. Solving for the cosine of theta pops right out. Cool, right? Now back to our regularly scheduled program. Cancel the norm of v and we are left with this. To get the actual vector, take the length and multiply by a unit vector in the direction of u. This gives our final formula for the projection of v onto u. This green dashed line is the orthogonal projection of v onto u. You can compute it by taking v minus the projection of v onto u. Sometimes we call this the projection of v onto u perp. How about some examples? In each of these cases, find the projection of v onto u. First, u equals 1, 3, and v equals minus 2, 1. Then the projection is given by this, which comes out to be 1/10, 3/10. We can draw this, and yes, the projection is tiny. Second, u equals 3, 1, minus 1, and v equals 1, 0, 2. Then the projection is given by this. The numerator here is just the dot product, and the bottom is just the length of u squared. I'm not going to expand this one, I'm just going to leave it like this. Finally, u equals 3, 1, and v equals minus 2, 6. Then the projection comes out to be 0. Why? Well, these vectors started out orthogonal, which kills the entire projection. It's like the example at the beginning where the dowel was vertical. You just saw the end, there was no width at all.